Okay, so we proceed with 1c. Okay, a thin film with an index of refraction 1.35 is applied to an automobile windshield with A above the film, for which the index of refraction is 1.5, right? So we have two information, 1.35, and then the one is a 1.50. C1. What is the minimum thickness of the film such that refraction of wavelength 500 nanometer light appears to be dark, appears dark. Right, this one refer to destructive interference because appears to be dark. Right. Okay, so if we illustrate in the diagram, so this one is it anti-phase or in phase? Because we have just like three layers A, and then after that a thin film, automobile, beam shield, right? Okay, if we have this one, okay, let's say we have a first layer, okay, a draw, okay, should be a straight line. Yeah? Okay, here is a in the A, film. Okay, then after that, the one is a automobile, windshield, right? So we have three. Okay, okay, what we can see here is a 1.0, 1.0. This one is 1.35, and then here the last one is a 1.50. Okay, okay, maybe we can decorate a bit. Decorate. This one no marks be given. No marks. We just draw. We just draw and we see how it goes. Okay, so I explain a bit about this one. Okay, when an incident, not ray incident. Okay, you have this one here, incident. Okay, incident. Right. Okay, incident should be this. Yeah, incident ray. Incident ray. Right. Okay, from less to denser. From less to denser. So, okay, first reflected ray. We have a first reflected ray. Okay, first reflected ray. And then after that, okay, from less to denser. From less to denser. Okay, first reflected ray. We look at it for first one. Right, you can see from less to denser pi change. Is there any pi change? From less to denser, if we have a less to denser, so there will be a pi change. Okay, a phase change, sorry, phase change. Okay, phase change. We have a phase change radian. Okay, and then pi radian. After that, okay, from here, second one reflected. So we have second. Okay, from less 1.35 and then to 1.5. So less to denser. Okay, second reflected ray, less to denser. So if from less to denser. So is there any phase change? So we have phase change. We also have phase change. Okay, phase pi change here. Here we have phase change. Less to denser. Okay, for first one, if pi change, you have like this. Okay, you have like this pi change. Okay, pi change, but reflected. So we just go through only reflected like this. Okay. Okay, we look at it after two reflected ray. Okay, first reflected ray, second reflected ray. So the first reflected ray, we have a phase change. Okay, pi radian, phase change pi radian, both also. Okay, therefore you have two reflected ray, coherent sources, coherent sources, coherent sources. Okay. Oh, same phase change, right? Same phase change. Okay, if both same phase change, means that in phase, in phase, in phase, right? In phase case, this one. Okay, this case is in phase case. If we knew this one is in phase, that means in phase, the first fringe that I get should be bright fringe. Okay, but the question asking about what is the minimum thickness? What's the minimum thickness when it appears to be dark? Okay, so we have to use the destructive interference equation, right? So lambda is given 500 nanometer, so convert to SI nanometer. Okay, 2 NTM, 2 NTM. So where is the first one? Okay, first TM, second means that like twice. Here, this one is like journey. Okay, twice. Okay, 2 NTM equals with km plus half. Okay, lambda. So this one is we use destructive interference equation because in phase case, and the question asking about appears dark, so destructive interference. So you plus half. Okay, plus half. Okay, when m equals with 0, when m equals 0 order, so this one we substitute 0. Okay, so for exam, you substitute 0. So, okay, you can substitute like this. M equals with 0. Okay, so we determine the minimum thickness, dm equals with lambda over 4n. Yeah, lambda over 4n. So substitute the information. 500 exponent negative 9 over 4 1.35. Okay, so I get 9.26. Okay, exponent negative 8 meter. If you want to put in a standard form, you can put, otherwise we put in an in terms of 92.6 nanometer. Okay, dm, the minimum thickness. Okay, acceptable, right? Okay, this one is the what's the minimum thickness? The minimum thickness. All right. Okay, so we proceed with our C2. C2. On the same windshield, what is the minimum thickness needed for which constructive interference of 550 nanometer green light can be occur by refraction? Okay, so this one constructive interference and the wavelength is given 550 nanometer occur by refraction. So this one we go for constructive interference. Okay, constructive interference because it says reflected light, okay, reflected occur by reflection. So constructive interference. So equation that I use for constructive interference equation 2n Tm, same thing, minimum thickness equals with m lambda, right? Okay, because of the constructive interference. Like when m order equals with 1. Okay, this one is order 1. We cannot put 0. We cannot substitute 0 because if we substitute 0, we cannot calculate no value. Okay, so Tm m lambda over 2n equals with, okay, substitute 1 order 500 550 exponent negative 9 over, all right, so 2, and okay, we take, so if we refer for C1, you look at the C1, look at the figure that I draw. So we take the middle, and we take the reflected, this one, medium. Okay, 1.35. Right? You substitute 1.35. 1.35. Okay, equals with, okay, you get the answer 2.04 exponent -7 meter. Okay, you can put it in a remain in a standard form. Otherwise, we can put in in terms of nanometer. 204 nanometer. Okay, you can put it like this, or you want to uh, put in a standard form, acceptable. Okay, right?